All right, so in assignment number 3, we're going to move towards graphing. We're going to graph 3 familiar functions, linear, quadratic, and absolute value functions. All of these you graphed in Algebra 1. So we're going to spend a real quick amount of time just reviewing what those general functions look like. But then we're going to spend quite a bit of time translating, reflecting them over the x-axis, and stretching those functions out by multiplying, subtracting, adding those functions by a certain number in a certain way. So let's go ahead and get started. Let's just go ahead and start by remembering how to graph equations in slope-intercept form. Remember y equals mx plus b. And so the b is the y-intercept. So in this particular case, the y-intercept is at -4. The slope, that's what m is. That is 2/3. So from -4, I'm going to go up 2 and over 3, up 2 and over 3, and I'm going to have a line that looks something like this. Didn't go through all those points very well, but you get the idea here. We can also make an x and y chart and plug in values. So if I plug in, let's say I plug in 0 for x, I'm going to get -4 for y, and that gives me this point. And I would get all of these points that are located on the graph by plugging those points in as well. So let's take a look at another function, standard form. So standard form can be graphed two ways. Standard form is ax plus by equals c, and I could find the intercepts by plugging in zeros. So for example, if I let x be 0, y, that means this is going to disappear. Y is going to have to be -3, which means I'm going to have the y-intercept at -3. Then if I let y be 0, this will be nothing, and 3 times 4 gives me 12, and so I'll have a point at 4, 0. And my graph will look like this. The other way that I could graph things that are in standard form is to put them in slope-intercept form by getting the y by itself. So I'm going to make the subject of this equation y. I'm going to subtract 3x from both sides, so I'll have -4y equals -3x plus 12. Then if I divide everything by -4, I'll have y equals 3/4 x minus 3. And you can see the y-intercept starts here at -3, and the slope is 3/4, so I would go up 3 and over 4. And I can continue to do that to graph the equation. So that's linear functions. Now let's move to quadratic functions. Here is the most basic quadratic function, just y equals x squared. We could make an x and y chart. Maybe you remember doing this in Algebra 1. We plug in -2, -1, 0, 1, and 2. Square all of those numbers. So if -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. And I have my points. -2, 4 is here, -1, 1, 0, 0, 1, 1, and 2, 4. And when I graph that, hopefully you remember the name of this shape. It's called a parabola. And so the basic shape of a quadratic function is anything with an x squared in it, is a parabola. And that's the parent function for a parabola. Now later on in this lesson, we're going to shift that. We're going to move it left, right, up, down, stretch it out, flip it upside down. We're going to talk about how that happens. So let's move on to our last general function, absolute value functions here. Here we have y equals the absolute value of x, and again we can make an x and y chart. We can plug in numbers like -2, -1, 0, 1, and 2. The absolute value means how far away these numbers are from 0. So -2 is 2 units away from 0, -1 is 1 unit away from 0, 0, 1, and 2. So we get these points, -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. And the graph is a V. And we can plug in other values. If I plug in -5, it would give me +5. So absolute value functions, whenever you have the absolute value around the x, the general shape is a V. The origin or the vertex is at the point 0, 0, and that's the parent function is what we're going to call it. So now that we have learned a little bit about what the parent functions of linear, quadratic, and absolute value functions look like, how are they changed? We can add, subtract, multiply these functions in various ways so that different things happen. And so just a real quick review, we've looked at the most basic linear function is y equals x, the most basic quadratic function is y equals x squared, and the most basic absolute value function is y equals the absolute value of x. Those are the parent functions. Now, those parent functions are going to be flipped, rotated, translated, stretched by either adding numbers, subtracting numbers, either before we square it or after we square it, or before we take the absolute value or after we take the absolute value, and then they're going to be multiplied by a scalar, the a values. And regardless of what the function is, those things that we do, the h, the k, and the a, all affect the graph in the same way, regardless of what the original parent function looks like. So how do they change the graphs? That's what we're going to talk about next. All of these things are called transformations. Let's take a look at the first transformation. We're going to subtract 2 before we take the absolute value. So we know that the absolute value of x, the parent function, looks like this. But how does subtracting 2 before we take the absolute value affect the graph? And so what we're going to do is make an x and y chart here, and I can plug in -2, -1, 0, 1, and 2 like I did before. But if I do it this way, I'm going to subtract 2 from everything before I take the absolute value. So it might be best in this particular case to figure out, how do I get 0? This point here is the vertex. How do I get a 0 in that function? Well, I'd have to plug in a 2. How do I get my y values of 1 and 1? Well, I could plug in a 3, or I could plug in a 1. 1 minus 2 is -1, but the absolute value is +1. 3 minus 2 is 1, and the absolute value is +1. Well, if I continue this, I plugged in 2, 1. If I plug in 0, here's 2, 3. If I plug in 4, well, I'm going to get 2 here and 2 here. And essentially what has happened is this. I now have my vertex at the point 2, 0, which is here. I have a point at 1, 1 and 3, 1. And I have a point at 4, 2 and 0, 2. And my new V, my new graph, is shifted 2 units to the right. So the key is, can we look at this function and see that it's shifted 2 units to the right before we even plot points? Well, let's take a look at another graph. So here we have a quadratic function. The parent function is y equals x squared, that we know typically looks something like this. Well, now we're going to add 3 to it before we square it. And so what I'm going to ask myself is, how do I get the vertex? How do I get a 0 here? Well, in order to get a 0 here, I'm going to have to plug in -3, because -3 plus 3 is 0, 0 squared is 0. Then if I plug in numbers around -3, like -2, -1, -4, and -5, -2 and -4, if I take -2 plus 3, I get 1, and 1 squared is 1. If I take -4 plus 3, that's 1, and 1 squared is 1. And here I'm going to get 4 and 4. So my new function would look like this. I'd have a point at -3, 0. Then at -2, 1, and -4, 1, -1, 4, and -5, 4, and I would get a parabola that looks like this, that's shifted 3 units to the left. So can we look at this function and realize that this is going to be shifted 3 units to the left? The big idea here is that when we add or subtract a number before squaring or before we take the absolute value, the result is a horizontal shift. A horizontal shift is simply a shift left or right, and it might be opposite of what you would think, because if it's +3, it's going to be shifted 3 units to the left. Let's take a look at another situation. Now we're going to be adding something after we square it. So again, we know the parent function looks like this. That's what the general function looks like. But what happens when we add a 2 after we square everything? So if I plug in my original values, -2, -1, 0, 1, and 2, and I square them all, I get 4, 1, 0, 1, and 4. Well, now what I'm going to do, that's the parent function. Now what I'm going to do is take all of these values here and add 2 to it. So 4 becomes 6, 2 becomes 3, 0 becomes 2, 1 becomes 3, and 4 becomes 6. So now I'm going to graph this point, which is -2, 6. And I'm going to do this in a different color. -2, 6, which is up here. I'm going to graph -1, 3, 0, 2, 1, 3, and 2, 6. And you can see the parabola now looks like this. The whole the shape is the same. It's not graphed very neatly, but the shape is the same. It's just shifted 2 units upwards. And so how do we know by looking at the equation that it's shifted 2 units upwards? Well, when we add or subtract after squaring or after taking the absolute value, the result is a vertical translation, a vertical shift. And so if this was a -2, I would go down 2 units. If it was a +5, I'd go up 5 units. And so adding or subtracting something after we have the operation on x shifts the whole graph either up or down. All right, so let's take a look at one last possible thing that could happen here, and that is multiplying whatever we're doing by a certain number. And so here we have the parent function, y equals the absolute value of x. We know that this is a v. It looks like this. But how is that v going to be changed if we multiply everything by -3? So let's start with our original values again of -2, -1, 0, 1, and 2. If I take the absolute value of all those, I'm just looking at this right here. I'm going to have 2, 1, 0, 1, and 2. But now what I want to do is I want to take those values and I'm going to multiply them all, these values here, by -3. So 2 times -3 is -6. 2 times -1 is -3. 0 stays 0. 1 is -3 and 2 is -6. So now I'm going to graph the point -2, -6. I'm way down here. -1, -3 is right here. -1 or 0, 0 is here. 1, 3 is here. And 2, -6 is here. And so you can see now the v is flipped upside down. What made it flip upside down was the fact that it's negative and it's stretched. So it's 3 times as tall, except it's flipped upside down. So the 3 stretched the graph, the negative flipped it upside down. And so the big idea here is that when we multiply the operation that we're doing to x, either squaring or absolute value, it stretches the graph. If it's bigger than 1, if this was a number smaller than 1, it actually squeezed the graph or shrink the graph, or it reflects it over the x-axis, so it flips it upside down. Let's review these things real quick. We started with these 3 basic functions. We're going to add more functions to this idea as we go throughout the year, but for right now we have y equals x, y equals x squared, y equals the absolute value of x. Then when we do these things, we either subtract something before we square it or take the absolute value, we add something or subtract something after we take the square or absolute value, and then multiply by something. Here are the changes that happen. The h in every situation translate or slides the graph left or right, opposite of what you would think. If it's -h, it moves it to the right. If it's +h, it moves it to the left. The k value translates the graph up or down, and that would be what you think. If it's a +k, it moves it up. If it's a -k, it moves it down. And then the a value either stretches or shrinks the graph, and it reflects the graph over the x-axis. So let's take a look at one more situation here. We have this graph. We know it's a v graph. The parent function looks like this. So the original function we know is a v that looks something like this. But now what we're going to do is we're going to take this, we're going to slide it 3 units to the left. So I'm going to just focus on this point here first. 3 units to the left would be here. Then I'm going to move it 1 unit down, which now I'm here. And I'm going to stretch it out twice as big. So instead of going over 1 and up 1, over 1 and up 1, I'm going to go over 1 and up 2, over 1 and up 2, over 1 and up 2. And I'm doing it from my new vertex that was shifted over. Same thing if I move to the left. I'm going to go up 2 and left 1, up 2 and left 1. And so my new graph looks something like this. And I don't have to plot any points. I just know what happens to the graph by looking at the 3, the 1, and the 2. And this is what we're going to be doing on our homework assignment for tonight. We will go over this in class tomorrow, and we will see you then.